Okay, folks. How's everybody doing today? Yeah, you guys are here late. I was worried that this was one of the last ones, and so you'll be ready to party or something. And I guess that's why you're still here for the party. I'm Scott Hunter. I've been at Microsoft for about 17 years. You might know me from the .NET days. I was involved heavily. I joined the company working on ASP.NET, and I was part of the migration of .NET Framework to .NET Core, which we started in 2014. We shipped in 2016. Now I work on a combination of the .NET stuff and some of the stuff in Azure. I've got a friend and colleague in front here. This is Paul Yuknovich. He's going to do a cool demo showing how you use functions and AI together. This talk might be a little weird. You might see, I hope you're going to see stuff you've never seen before. That's kind of the intent, is stuff that you just haven't seen. I'm not much of a slide person, so this is actually a demo that we did at Build. And what we wanted to do is take an older application. Does anybody here work on an old app? Okay, good. You know, if you follow Microsoft, all we do is talk about all of our newest stuff all the time. We talk about .NET Core or .NET 8. We talk about Aspire. I'm going to talk about Aspire tomorrow morning, so please wake up early enough and get here. An hour of demos of Aspire will be a lot of fun tomorrow morning. But we do know we have a lot of customers that are on old stuff. And how do we help customers that are on old stuff move forward? And so what we did is we're going to take an application that we built when I worked on MVC. The app is actually 10 years old today, I believe. It's the MVC Music Store. And we're going to move it to the cloud. And then after we move it to the cloud, we're going to show how you would actually use some of the AI tech to find some of the services you might want to use to make the app better in the cloud. And then it gets really cool. This is an old app, but we want to scale it. And so we're going to take Paul in the front row here. He works on Azure Functions, and we just released a new version of Azure Functions that scales at this incredible rate. So we're going to go yank a piece of the app out, put it into Azure Functions. We're going to scale it to, we're going to throw a lot of load at it, over, I think, 1,000 users hitting it at the same time. And then, you know, I'm sure while you've been here this week already, who has been to a talk about AI? In many cases, when you do these talks on AI, you've probably seen all these deep coding stuff and hallucinations and all this kind of stuff. We're going to take this old app that I don't want to touch the code for anymore, and I'm going to hook some AI to it without writing any code. And then I'm going to actually do something crazier. I'm going to actually ask the AI to help me increase the sales of my product. We're going to show two sides of this. After that, I'm going to show an optimization feature that exists today that I promise nobody in the room has ever seen or used. That's a problem that we have. Literally, the AI in Azure can look at your app and tell you why your app is slow. It can actually show you the code fixes to make it better. Who has used Code Optimizations? Not a single hand. Perfect. You don't count. And then I'm going to have Paul come back up, and after I show the low-code, no-code version of using AI, we've also built, and we shipped at the Build conference in May, we shipped these amazing extensions to functions that make building an AI app in what, like 10 lines of code, Paul? Yeah, so about 10 lines of code. So you probably saw lots of code this week on doing Gen AI, and we're going to show how to do that in a lot less code. So that's kind of the pitch that we have today. And we'll try to be demo heavy, because that's what I like. Skip all that, marketing wrote that. So who in the room has ever used or even knows we have a tool? If you have an older .NET application, does anybody know that we have a tool that will help you move that to the cloud? Not a single person. Not surprising as well. So we built a tool called the AppCat tools. We built a Java version, and we built a .NET version. We shipped those technically at Ignite last year. That would be November timeframe is when we would have shipped those. And I'm going to actually use that for this. This is the marketing slide that kind of talks about that. And this is the actual real slide that talks about it. It lets you move an app to a variety of different places, and it's available today. You just don't know it's there, and I'll show that. We'll start with that. So let's find a Visual Studio. This is the right one. And let's get rid of that. So this is MVC Music Store, and if I go back to my browser, I've got this repo. We actually wrote this in MVC3, so that's how far back this thing goes. And then we ported it to MVC4 and MVC5, and then I asked John Galloway, who's not here this cycle, could he help me move that thing to make it work today? And so we brought it back alive. But what I've got here, if I go to my Visual Studio and I go to my extensions, I'm in the right Visual Studio, and I manage extensions, and look and see what's installed here. Notice I have a couple things. The .NET Upgrade Assistant, that will move you from a version of .NET to the next version of .NET. That's also a tool you probably don't know exists. If you're on .NET 7 and you want to move to .NET 8, this tool will move you from those two .NETs probably in 3 seconds. It'll go from 6 to 7, 7 to 8. It'll try to go from framework to core as well. I'm not going to show that, but if you've never heard of it or seen it, find it. The one I'm going to show today, also you probably have, this is the one that nobody raised their hands on. This is the Azure Migrate application and code assessment tool. It's installed in my Visual Studio, and so I can go take this old app, and I can right-click on it, and notice that there is this replatform to Azure. And so what this tool is built by us because we have plenty of customers that call us and say, can you help us move our applications to the cloud? In many cases, we go out and help a customer. We'll do a proof of concept with them on one of their applications. And this tool is literally all the stuff we learned from those proof of concepts. So what I can do, and we put Copilot in here as well. So I can say I want a new report. I can choose what part of Azure I want to move this thing to. And notice you've got things like container apps, you've got app service, all the good stuff, Azure Kubernetes Service. So we can move you to a variety of different sources. In this case, I'm going to choose Windows, App Service Windows. And then I can choose which projects I want to actually have the tool run on. And I can choose whether I want to look at my source code and settings, or do I actually want to look at binaries? Do I want to look at the DLLs that you might have sitting in folders that could matter that we can help you on? And I just click the Analyze button. And what you get is a pile of information. And I'm going to sort these aggregately. And this is going to show me, there's a couple of mandatory things here I must fix. And so one of these, if you're building on-prem applications today, this is saying, hey, you're using Windows authentication so your application can talk to your SQL server. That's not going to work in the cloud. You're going to have to do something different. I have another one here that I can open up. This one is telling me that in app service, this app is actually targeting an older version of framework, 4.7.1, and app service runs on 4.8.1. And so it's saying, you don't have to do this, but you might want to do this just to check and make sure it works perfectly before you go up in the cloud. And I'll show one more of these right here. This is an interesting one right here. This is saying that, once again, this is an old application. It's going to have its connection strings just sitting in a web config file. Bad. You don't want to check those in. And so what it's going to do is it's going to recommend moving to a connection builder. That's tech that we built in later versions of .NET, where you can actually swap in something different there. And so for fun, you'll notice that every one of these that I've shown you so far has an Ask Copilot button. So I can, not only will it tell me what it thinks I should do, I can go ask it to explain to me what this really means. And we'll see how long it takes the Copilot to burn the GPUs in the cloud somewhere. But I said we have this Copilot button on every single thing that's here. And we had a customer that told us that they were able to save 80 hours using this tech. So basically it's telling me, hey, I should probably use this configuration builder where I can put my stuff in a better place. And I could say, you know, would this help me use Azure Key Vault? So Key Vault is the tech in Azure where you should store things like connection strings because it's going to actually, it's encrypted and they're not in plain text. And it's going to say, yeah, that's exactly what you would do. And it's going to tell me how to actually configure this to use Key Vault if I want to have the most secure connection strings in the cloud. So I'm going to cheat now. And I'm going to, you don't want to watch me fix all those things. So I'll just go to the, no. Boom, I've just changed the code. And so since I've changed the code, I can go back into that, let's go back over here. Yeah, I know there's security vulnerabilities. I can right-click over here, go back to my replatform to Azure tool, make a new report. It got mad because I really changed the branch. And so it reset me here. But if I run this again, and the right things have happened, look at that. I fixed almost everything for this. And so if I go look at the aggregates, I have nothing except some optional stuff now. And even some of these make sense. It's like telling me right here, I would be better off maybe putting my images and stuff in a CDN versus in my app. But now the app is ready to go, and it's in the cloud. So let's go to the portal. And I'm not going to publish this while we're sitting here. Ooh, service issue. And here's the app in the cloud. I've got a copy of it running up here. You can see the Azure URL here at the end. Come on, Zoom. Zoom what I want. Or don't. But it's got an Azure URL, and you can see this is a really fancy looking application. But it works. And so now we're in the cloud. Now I'm in the cloud. Once again, I can use Copilot for other things. It's like I can come up here and say, this is a new feature. This is Azure Copilot. And so you can start asking Azure lots of questions like, what other services do apps like mine use? And Paul and I are going to show you a different flavor of this as well. Where this is first there's the Copilot. The problem with the Copilot is you have to actually click the button. You have to ask a question. You might not know what to ask. But it should come back and tell me that SQL databases, Redis caches, App Insights are the types of things that I would want to use. I can scroll up, take a look at that. There's my SQL. There's my App Insights. These are the things that I should probably be using. Defender for app services. This will make sure that you're not using old NuGet packages and stuff like that in your app. So these are things I might want to use. I could also do things like go up here and say, that's not what I wanted to do. I will tell people this thing's a little buggy, so I just start a new chat. What service would I use to add distributed caching? Now this isn't fair because I'm actually asking questions. You might not care about these questions, but I'm going to show you a different side of this in just a second. So it should come back and hopefully what this actually does is it looks at all the app services out there, and it looks at what types of caches they're primarily using, and it's going to recommend to me hopefully the Azure Redis cache. There we go, Azure Cache for Redis. But as I said, the problem with this is you have to have those questions in your mind. We made a mistake, and we actually used a code name that we put in the portal called Better Together. That's actually something we build internally. Paul's laughing because we both saw this a couple days ago, and we're like, we're not supposed to put code names in the portal. This should actually show what other services should you use, is what it should say. But it's going to recommend similar stuff. It's like a front door in front of my application, a Redis cache in my application. And it's even better than that, because if I click the Create button here, notice it only asked me two questions, the name and the SKU. If I actually wanted to create a Redis cache, it's going to ask me a lot of stuff. Here's what a real Redis cache wants to ask me, do you want all this stuff? Networking, I'm not going to go click through all these things, but there's a whole bunch of things here. There's basics, networking, advanced, and what's going on here is the better together, which will disappear, is basically telling me it knows already what resource group I'm in, it knows the location I'm in, so it can reduce all those questions down and get you hooked up super, super fast. The next thing we're going to do here is we're going to have a co-pilot here as well, that not only will we actually build the service for you, but the co-pilot will then help you put the actual tech into your application. And we call that better together. Code word that should not be seen by the public. And I even put a slide here. Cloud service recommendations, best practices, all in the portal. That's better together. The next thing we're going to do is we're going to do some scale stuff. And this is Paul's tech that he wrote, or his team wrote. One of the things that we've had functions in Azure for a long, long time, but one of the things that's super important to our customers is I want these things to be able to scale at incredible rates, because if you're building a music store and suddenly a lot of requests come into your application, before it would take functions, what, a couple minutes, Paul, to scale up? What happens during those couple minutes? Imagine you have a huge, it's a shopping weekend around a holiday, all this rush comes in, and what you're going to do is you're probably going to say, I'm not going to trust the scale up, I'm just going to go set the number to a higher number before, because I don't trust the scale. Now this thing will let you actually scale from 0 all the way to some crazy number, and then when the load goes away, it goes back to 0. And we're going to show that live. Another thing is security is something we really care about at Microsoft. You might have heard in the news that we talk about it a lot internally right now. And so another feature that people have asked for is in the functions world is they want VNets. And if you don't know what a VNet is, I might not want my function to actually be on the public internet. If all I have is my web front end calling that function, I want that function to be hidden away in what we call a private virtual network. And so Flex Consumption Functions support that. And while Paul's here, I'm going to, Paul, the naming, man, Flex Consumption Functions, oh my gosh. Too long. And then finally, we like to think of most of our services, things like Azure Functions, Azure Container Apps, we consider these to be serverless platforms, which means I said before, you can scale them to 0 and scale them right back up. And so, if you want to not get the lowest Azure bill and have us make no money, just use this tech. And so with that, let's go back to Visual Studio. And what I'm going to do here is I wanted to highlight this is basically the MVC Music Store, and so it's going to have its. I'm in the wrong one. Showing the wrong VS. Let's go back to this version of Visual Studio. And I'll close out my report. Don't need that anymore because we're already migrated to the cloud. And close that out. And I've got a store controller here. And my store controller is going to do all of my purchasing and stuff like that. And it's going to do order processing. And what we've done is Paul went and took that method out and put it into a new project. So we're not going to change the whole application. We're just going to take one piece out and move it to another application. And I will switch to the other VS, and we'll show that. And so there's a couple things here. If you've ever tried functions in Azure in the past, they weren't super friendly to ASP.NET developers. You're probably used to, I was part of the ASP.NET team. We built Web API. It does model binding, where basically we take all the parameters to your method. We automatically serialize them. You don't do the manual stuff. Functions before required you to actually do that serialization yourself. Basically, you just got a request object, and you had to go suck that stuff out of it. And then also, all the features that you have in the ASP.NET Core pipeline, you kind of lost as part of that. And so I already saw over here that I've got my logger. So I'm back doing regular ASP.NET Core style stuff here. I've got my method here, and you can see it's basically mapping to the same URL that I had. I didn't really show the code in the other one. It maps to the same URL here, and this is where the new stuff comes in that we have now. There's the from body attribute, and that lets me just put an order there. As I said before, you would have taken a request and you would have parsed this stuff out yourself. We want to make it very easy to basically copy and paste something out of a controller into a function and make it work. It's got the shopping cart ID, it's got the URL, it's doing the model binding, it's got all the logging stuff here, it's good to go. I do want to show as well that not only do I have all of this, but I can also run this stuff locally. So if you've never tried Azure Functions, the runtime for it works everywhere. We have basically we're running the runtime on my local machine here. You can see it boot up. There it goes. It's got the same URL. And then I can go back to over here, and I'm pretty sure I have a test HTTP. This is a feature we added recently where you can put a file in to simulate request. I can send that request, and my function should work locally. There you go. It came back with my test data. Now that's great. Let's move this to Azure, and while it's in Azure, let's show that we can scale this thing at crazy, crazy levels. Okay. So I'm going to go back to my portal, and we'll close out this. Let's move over here. Here is my function running up in Azure. And I can show up here that I'm in the wrong place. Let's go to Overview. And you can see it's got that fancy name that Paul gave it, Flex Consumption. So it's got this new scalability feature in it. And if I scroll down, you can see here's my function right here. I'm going to jump ahead for a second. I'm going to go and show you the metrics on this right now. And so notice we have no traffic, 0 instances of one server online, 0 to 1 server online, but there's no traffic really coming in right now. But we have another thing. I'll laugh and say we were showing that better together. Notice if I come over here and click better together, one of the things it's going to recommend is, I hope it's going to recommend, Paul. There it is. It knows that because I'm running a function, I might want to actually run a load test to make sure my shopping cart's not going to die when we throw a lot of traffic at it. And so if I click that, it'll actually go through a wave of letting me build that test easier than normal. But I'm not going to focus on that right now. I'm going to go back over here.
Actually, can you run it?
Run what?
Can you run the load test? I don't have access to it. I have another one. Security.
Oh my gosh. So one of the things that's changed, just a funny side note, security is so important to us that when we do demos and stuff like this, we're not allowed to keep the stuff very long. They don't want us to have just random stuff running in the cloud, and so Paul is saying that they deleted our old instance, and I have not given him access to the new one that I have here. I want to show a couple things here. So load test service, this is a great service we have that basically creates an AKS, a Kubernetes system behind the scenes, and can boot up a bunch of agents to beat the heck out of your app. And so I can go to configure here and test. And you're going to see basically, here it is. I got my process order one here. I can open this up in the portal. It's got that same request that you saw before, that same URL. So I put the URL of my running application into this. I can go over here and click on the body. And pretty much what you saw me testing in the when I ran it locally, it's the same fake data. We're going to take this and we're going to send this to the app 1 million times. And so if you've never tried this service, it's really, really cool. Scroll back up here and cancel out. And maybe I'll show load. This is interesting as well. I have 5 engine instances that I've got configured here, and each engine has 50 users running inside of it. And that means that I've got over 1,000 users. So we're going to basically take 1,000 users and boot them up and blast them at the function and see what Paul's tech can actually do. So let's go out of here. And I have to do a new one, right, Paul?
Yeah.
Run?
It takes 2 minutes.
And this is NDC. So I just started that test. And so, as I said, what actually is going to happen behind the scenes is our AKS is going to boot up. It's going to create 5 VMs. And when those VMs boot up, it's going to start sending traffic to my function. And so now we're going to really get to see the total ramp, Paul, since normally what happens is Paul sits in the front row, and about a minute and a half ago, he presses that run button, which means the load will already come and hit us. So we're going to have to wait a second.
I have another one if you want to see.
What does the other one do?
It's the same thing, just a copy. Akka.ms/scott.demo.
Okay, so
It's the cloud, you need backups.
what is it?
Scott demo.
So what happens faster, the portal loading? There we go. So while we were talking, Paul spun one of these up on his own machine, I think. Where's that, Paul? There we go. I bet you the other one's actually going by now. Let's go see. Nope, that one's still slow. Yours is slow too, Paul. That was so much faster.
There it is.
Ah. There you go. So if you're watching, it was at 0 when I first moved over here. We got perfect timing. We have 9 servers that we went from 0, and 1 second later, 9 servers existed. We have never in Azure had the capability of being able to boot something up that fast. Because literally behind the scenes, imagine we're booting up a virtual machine, we're putting the function stuff in it, and we're running this. You can see I've got a ton of requests coming in now, 3,000 requests per second. We're now at 18 servers, so we went from 0 to 9 to 18 while you're sitting here in the room. See if it'll go any further. You can look as well and see things like, I love this one. Paul was telling me that notice that our CPU is only running at about 50%. If I'm paying for it, I would actually want to run my CPU probably at 75 or 80% and leave myself 20% of leeway. And I think we have a feature called concurrency where you can dial how much load we'll actually let each instance of your functions actually have. But now, look, we're at 26 servers, and so just me talking on the stage, we went from 0 to 9 to 18 to 26. I think you should give Paul's team some applause, because I think it's pretty cool. Yeah, that thing is rocking. Let's see if this one is, now mine's going too. So my bosses, they just paid us, what, $600? That was $600? So the fun thing about load test is if you go throw a lot of traffic at it, we just booted a whole bunch of hardware in Azure up to make that happen. And so we laugh. I'll tell you, load testing is amazing, but you have to be careful with it because it is expensive because we boot up a lot of hardware to throw that kind of traffic at your,
Maybe 5 minutes.
Yeah. We run it for 5 minutes. I jokingly, before we came out here, one day I ran it for 20 minutes. Oops. My bosses do notice, by the way. So, the final thing to show is we mentioned before virtual networks. And if I go down to the networking, you're going to see that I do have a VNet attached to this as well. Here's my virtual network right here, which means we're doing all the best practices in Azure. Our function's not publicly on the internet. You folks in the room couldn't call it. It's impossible to call it because it's netted away somewhere. And so that is that. Okay. Let's go back to these slides. Now this slide is really useful. There is no way in heck you can read that stuff on the left. Thank you, team. for producing this. Who in the room has ever used a Logic app? Oh my gosh, that's way more than I expected. I want to come talk to you afterwards and hear how you found out about Logic Apps. Logic Apps is part of a technology we call integration. Basically, it's a way, a lot of folks have used expensive software packages that they buy to do integration. We had something called BizTalk that was very similar. We still have BizTalk, but we had something, BizTalk was our on-premise kind of integration tech. What integration really is a kind of a low-code solution where we have a whole pile of connectors, and you can say when some data is dropped into a storage account, I want to go copy it to AWS storage. I'm making up random stuff. Or when somebody puts a ticket into Salesforce, I want an email to happen. There's a variety of things you can do with that. And one of the things that's really cool is, and if you're in the room, you're going, I don't do low-code stuff or no-code stuff. We have an enhancement to functions coming out, to Logic Apps coming out later this year that's going to add some programmability to that. Paul's grinding his teeth. But we've actually added support for Azure OpenAI and for Azure AI Search to Logic Apps. And so I can take this old MVC music store and I can add some AI stuff to it. So let's see what that looks like. So currently I'm in trouble from my team because I'm supposed to be in a meeting. This is true. And what I'm going to do is go over here and jump into this. And this is a Teams channel. And so what I'm using is I'm using a Logic app that can actually integrate with Microsoft Teams. And notice down here it says, provide insights and recommendations using sales data on how to improve album sales. And so I'm going to send that message to Teams. And when I do that, Logic Apps is going to kick off. It's going to run an AI query against my MVC music store, and it's going to come back and tell me some intelligence. I think. And I will, once it does that, I will explain, there you go. So it just came back. And I do all of this without actually changing any code in my application, which I think is a cool thing for dealing with an old application. How can I AI-ify it? And so notice what it said here. It's like, it said, analyzing sales data based on genres can provide insights into most popular genres. It's going to talk about identify the artist with the highest album sales. It's basically giving me a bunch of ideas based on my SQL data on how I might actually improve my sales. I'm going to try something funny here. I'm going to copy that. Who's heard about hallucinations this week? Let's do it one more time for fun and see if we get the same result. And then I'll show you how it works. And then after I show you how it works, we'll have Paul come up and show you how you can do something very similar with functions. Let's give it a second here. This is another fun thing is that this Logic app does, now it gave me even more stuff. So this is your hallucinations in action. Notice now it's saying that jazz albums, blah, 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 are top-selling albums, therefore investing more in jazz albums can help boost sales. Rock albums such as Queen, AC/DC are also popular. Expanding rock would be a way. And so literally you can get some pretty cool insights from AI. But you might ask, well, Scott, how did you do this? And let's go back to my browser. And first off, this is the actual way that we actually trained this data. So what we did here is we made a Logic app. The Logic app is going to be hit when you hit a URL. It's going to run this code, and it uses the SQL connector to go and just write a SQL query on my database from my old legacy application that goes and pulls all the sales information out. Once it does that, it's then going to call into another logic app that I have called ingest data, and we'll show that in a second. And once that's done, it'll come back and return, yes, I succeeded, I'm good. So let's go look at what ingest data does. And there's just a couple things to highlight here. Let me go back up here. In fact, let me jump back over here. And while I was in the SQL one here, just want to show you some of the craziness that goes here. If I click plus and add an action, you are going to see this huge list. There's over 1,400 connectors for logic apps to a variety of data sources. No. And what I'm going to do is come over here. That logic app is then going to do a couple of things for me. It's going to first take all that data, and we know that you just can't take a pile of data and send it to any of the AI tech. So we're going to first chunk and tokenize that. And if I click over here, you can see that I'm actually using just an HPT connector to do that. I'm calling a REST endpoint. Where it gets kind of cool is down here. I'm going to go, and then this is using my OpenAI connector. I'm going to go and get the embeddings for that. And then once again, I'm going to then go take those embeddings, and using the Azure AI search connector, I'm going to go put those in a vector database. So I'm sure you've heard all this stuff in talks this week, but notice I did this without writing any C# or any C++ or anything at all to do that. And when I'm done, I've actually put all of that stuff in my vector database, and now I'm ready to make a query. And so if I jump over here, and I'm going to now show the Teams connector. And so what happens here is this is the Teams connector, the Teams icon here. This will be my Teams connector. And basically, it's set to basically look at a channel. In our case, it was the build demo chat assistant. And it will look for a word, prompt. If I see the word prompt in a Teams channel, I'm going to go run a logic app. And then what it's going to do is it's going to basically invoke the workflow for every prompt to go and make an AI query. So let's show that. So this is the AI query. The cool thing about everything I'm showing you right now, I mentioned before, I'm doing this from a SQL database. You can take this logic app as it is, remove that one step, and add a step to go grab that from a Cosmos database, to go grab that from a storage account, to go grab that from the file system. There's a ton of different ways you can actually. So the same logic works. It's transparent across all these things. You don't have to write the code. And so once again, you're going to see that I'm going to go over here, and I am going to go, once again, using my Azure OpenAI connector, I'm going to go search. I'm going to get the embedding back. I'm then going to go do a vector search using my OpenAI search. That's my vector database. And then from that, I'm going to get the chat completions from OpenAI, and I'm going to return those. And that literally is how we do AI with logic apps. And so if you've never tried logic apps before, and you want to go take some data you've got somewhere and do RAG with that data, this is a great way to get started. Now, before I show optimizations, Paul, maybe are you ready to come up and show the AI bindings? So, you know, I know people in the room are coders, and so we're going to show a code way of doing this that is way less code than anything you've seen so far. I don't know how we grab you a mic. Are there people in the room that can actually, do we have a hand mic we can use? Perfect. And as I said before, the logic app stuff, if you're anti-no code, we'll have a way for you. Here you go. Test.
Awesome. Thanks, Scott. Everybody? Testing? All right, there we go. All right, so Scott showed Logic Apps have a lot of superpowers, like the connectors are just amazing. Whether you saw Teams, there's things like SAP, the list goes on. So Logic Apps is really good for that. I think Functions is more when you're at home with 100% code. And we've got a programming model, and we've got the scale that Scott showed. So you can keep going. You know, in the continuum, Functions give you a place to keep going. The two work together pretty good, too. So what I'm showing here, this is actually one of our super popular samples for using AI and doing RAG, Retrieval Augmented Generation. And you make fun of Flex.
I didn't make RAG up. That RAG's not a Microsoft term.
RAG's a pretty pitiful name. Anyway, so so you can see this is super popular. Look at all the forks and the stars. But even the README kind of scrolls on forever. And if you look at the code, it does make use of functions, but it does show you there's about several hundred lines of code in the front end, which does the embedding, and also in the back end. So let's say here's the piece that does RAG, and it uses nice SDKs like semantic kernel. But you're looking at 700 lines of code, and you're learning concepts like data points and
so if you take a picture of that,
tokens.
if you take a picture of that URL, that is actually the C# OpenAI search demo we built a couple months ago.
Yep.
And it shows how to do exactly what I just showed you in raw C#. But as Paul said, there's 700 lines of code in just one component of this.
There's really a lot.
There's a lot.
A lot of boilerplate just to get going. So we thought there's a better way. And let me just show you. This is a very similar app to what Scott showed. So I can ask a question. And I guess my typing speed is hindered here. So does my plan cover?
Does my plan cover
Eyes.
eyes? This is the OpenAI search one, right? This is the big one, or is this?
We might have to do a refresh.
You don't have a live one, Paul. I don't think that one's going to go, Paul.
Yeah, I don't think so either.
700 lines of code is too much code, and so this one's not going to be happy. Why don't we show them the shorter version?
We'll keep going, yeah. So we'll show you the shorter version. So here's the... now we're down to just actually 3 key files. And actually, there's a great feature called Zen mode. I learned this from another colleague. Ooh, Zen mode. It's all code. So the first function is just uploading a file. So this is business as usual. I can take a stream of files. There's nothing new about this. But now what you'll see is when I queue up that work, I simply can have things like these new embeddings trigger. And the embeddings trigger and binding can basically do all that work for the vector embeddings just by adding this one attribute. And a couple kind of style points here. You can choose your model for embedding, so it can be any of the deployments. You can choose your vector database. Right here, I'm using OpenAI, but there's other great vector databases out there like Cosmos DB and Redis, and the list keeps growing. The industry has some. So the nice thing, functions, as you'd expect in code, you have a lot of flexibility, and whatever you can write, you can use. So to do embeddings, that's all the code you have to do. It's very concise. Let's keep going. So the ask function, if I want to do a semantic search, I use the semantic search trigger, and I can take the prompt from the user and have my own kind of system prompt. So here's the prompt from the user. Here's the system prompt. And again, I can wire in my choice of models. And that's all I had to do. I just use this attribute, and I'm going to return, as a POCO object, or POJO, I'm going to return the set of search results. So you can see just how easy that gets. Then functions will let you take it even further. We have some more triggers and bindings for AI. So here's one called assistant skill trigger. And if you've heard of function calling in OpenAI, this lets you just translate natural language into an actual function call. So this is super handy if your model doesn't understand the answers to some questions, but you can call an API. Very classic example is I want to look up employees in my Active Directory or my Entra directory. When someone asks about employees in a prompt, I can kind of say, hey, whenever you see that prompt, just call this function, and off you go. So in this case, we extended this RAG to be able to make to-do and calendar appointments just by calling this function, and that happens just by using this natural language. So you can see, hundreds of lines of code reduced down to about, 4 or 5, and then you can just spend time coding custom.
Code your app, not
Yep.
not code the AI.
And I guess let's just see if it's going to cooperate one more time. Oh, it actually did.
Well, can you query it?
So what I was just showing there, Scott showed you the burst scale example of flex consumption, and I'm showing that that kind of new superpower of burst consumption works well with AI too, because a lot of when you're working with AI is massive data ingestion. So we're showing here, just one file turned into one request, which turned into one function instance or server that went online. If I went and did more, so let's do a whole bunch. It looks like about 15 or so, would we guess? No problem. And
4 servers?
Yep, we're going to start bursting up here. Kind of depends on what I set the concurrency to, but just to finish the point on that, with concurrency, all that really means is you can set how many events correspond to how many instances of a function will you make. So if I have a concurrency of one instance and only one instance will handle each parallel request. If I have a concurrency of 10, I'm going to push 10 messages or requests in parallel to a function. So it gives you a lot of flexibility, and this is kind of showing in a visceral way. If I really crank down, if I crank down the concurrency, I'm going to give more CPU power, but I could go the opposite and get more efficiency and save money. So.
Are you going to query it again?
Oh yeah, sure. I think that was.
Or was that
I think we did it. It was quick.
We did uploads. We didn't actually do a query.
Query. I see what you mean. All right.
I want to see it work. Bingo. Yeah.
Awesome.
So basically, he took the same. If you ran that huge .NET application, he did the same thing in 30, 40 lines of code.
Yep. And that was asynchronous, and I used messaging, and even with all that, it was still.
And it scales up and down really fast, and so as you pump data into it, you're getting all that cool scale.
All right, thanks, Scott.
So let's show the next feature you've never seen before. This is code optimization. I had not seen this by myself. Being honest, I had not seen this myself until just recently. There we go. Okay, so let's go back to Visual Studio and make sure I'm in the right one. Not that one. We'll go to this one. And I showed you before, I've got this app in the cloud. So let's open the browser, and we will go to the app in the cloud. And what I'm going to do is let's go back up here. And we'll go to Overview. And if you turn App Insights on for your app service, does anybody knows what App Insights is? Has anybody turned the App Insight profiler on for your code? Not many. Okay, Azure, do your thing. So if I look at this application, I can scroll down and notice that my server response time is all over the place. That means that sometimes I respond quickly, sometimes I don't. That indicates I probably want a kind of flat kind of line there. I don't want a line this way or a line that way. I want more of a flat line there than what I have. And if I go look, I can see that I have no fails. So I'm doing well with no fails. But I'm having this server response time problem. And how might I solve that? Oops. So a couple things to show here while I'm goofing around is, I think I go down here. And here is the profiler. And notice you can see a couple of those bursts that are in there. I can do cool stuff here. I can highlight. If I want to drill down on a section, I can just focus on it. It'll show me more details. Over here, each of these triangles is a time that we took a snapshot of your perf. And each of those is kind of a trace of what's going on. I can come over here and, once again, look at that big one. But this new thing that's down here is, notice I have these top 3 code optimizations. So this is a new feature. This is code optimization. So if you just turn the profiler on in your app, running in Azure, you're going to have access to the performance tab. You're going to be able to come over here, and you're going to see these new code optimizations show up. So let's go click one of these. It's like memory is excessive. And so this is using AI behind the scenes to make this work, by the way. So if I come over here and look, I've got a couple things here. I can click on each of these to see what it is. But this first one, it says queryable.single is causing unusually high memory allocations. Why is that? If you're, before it tells you what to do, let me see if it already told you what to do. Yeah, so it's saying that we thought that it should be less than 1%, but we're seeing 29% memory allocation when this happens. And if you don't know why, anytime you call that method, we have to go look at the entire collection before we pull the first one out. And people in the room probably know the right solution here is going to likely be calling first or default. That's what I should actually be doing here to make this work. And so notice this code fix suggestions available via GitHub Copilot. So I'm going to go back. So I've got a couple things that told me I could do to make this app faster. Just by changing that single to a first or default, I'll use 29% less memory. Memory is CPU. Memory makes your app slow. And so let's go back to Visual Studio. And once again, I'll show in Visual Studio the magic that makes this work. So I'm going to go over here and open the GitHub Copilot in my Visual Studio. I'll open a new window. And I should be on the right branch. And there is a way to actually ask Copilot to go do these code optimizations. I'm going to cheat because I have way too many things in the cloud. I get conflicts doing this stuff. And so I'm going to copy this and paste it over here, and I'll explain what this is. So this is saying code optimizations /connect. And if I only had one MVC music store in the cloud, I could just say MVC music store. For all of you in the room, you probably don't have like 30 of the same thing in the cloud. But in my case, because I have a lot of them, I actually gave it the GUID of the app service that's running. And so it can actually go out and talk to the correct one. So we'll run that. You are connected to this. Let's see what issues there are. Boom. So basically, when we were in the portal, you would have seen it found a couple of issues. Here's the 4 issues. And then down here, it actually found those same portal issues. And now it's giving me full recommendations of how to change every single one of those. If I want to make a change, notice it's giving me these links. These links are basically the fixes. It'll write the code for us to make the fix. So all I've got to do is click. If I want to go fix that single to not be using single, I click the button. And it's now giving me a preview inside of here what to do. But I click the preview button. It loads it right in Visual Studio. And it's going to show you, there's the single, and it's going to recommend that I change that to first or default. I think that's a cool feature. What do you folks think? Come on, some applause for that. That's a good feature. So if you want to try that, you can actually just go and take a picture of my screen, and you can grab this code optimization. Search for that in the marketplace. You'll find that. That's brand new. It'll tell you how to go turn the right things on in App Insights on your application. Let your application run for a couple of hours. Go to the Performance tab, see what it found, and then right from the portal, look at those things and figure out what you want. go and connect it to Copilot over in Visual Studio or VS Code. This works in VS Code as well. That's not tied to Visual Studio. Something else I should have said when I was over here. Notice that I can also do this. I could decide, instead of doing the fix like I just did, I could just say create a work item and tell one of my engineers to go work on that and make that change for me. And so I think that's about all my time. I hope you all saw something you've never seen before. That was my goal, is to show stuff that you don't see, not this common file new, whatever. Most of you probably haven't seen Logic Apps. You have not seen the code optimizations. You've not seen some of the function tech that we have, or the way that you could ask the portal to help you do stuff, or even migrating to Azure. As I said, I'm here back here tomorrow at 9 o'clock in the morning, if you're not hungover, and we're going to do a whole hour of .NET Aspire, which I'm super excited about. So thank you so much, and I will see you tomorrow, hopefully.